Everyone, this video demonstrates assessment 3 for routing and switching. The network is based on assessment 2, which connects two branches of the company located in Sydney and Melbourne. And as you can see, this is the topology we have created during assessment 2. And the purpose of the video is to explain and justify the recommended network improvements and to demonstrate a secure point-to-point VPN communication between the two branches, that is Melbourne and then the Sydney branches. In assessment 2, the network was successfully designed and implemented using VLANs, inter-VLAN routing, Ether channel, access control list, and RIP as the routing protocol. However, the company later experienced delays in communication between Sydney and Melbourne as well as within the Melbourne VLANs. So I basically agree with the company's concern because these issues are mainly caused by limitations of the routing protocols and lack of redundancy. So RIP is simple and easy to configure, but it has low convergence, uses hop count only, and does not scale well for enterprise networks. Protocols such as OSPF or EIGRP offer faster convergence, better routing decisions, and improved scalability. In addition, redundancy strategies such as multiple routing paths and Ether channel help reduce single points of failure and improve availability. So for this assessment, the routing protocol choice is secondary. The main focus is secure point-to-point VPN communication as long as connectivity between the two sites is successful.
To improve the visibility and monitoring of the network, SNMP, Simple Network Management Protocol, was implemented as the network monitoring solution. SNMP allows network administrations to monitor device status, interface usage, bandwidth consumption, and detect faults in real time. It is low cost, scalable, and widely supported by network devices, making it suitable for the enterprises or network. Using SNMP improves proactive troubleshooting, performance monitoring, and network reliability. The primary objective of Assessment 3 is to implement secure communication between Sydney and Melbourne branches. To achieve this, point-to-point GRE VPN tunnel was configured between the two routers.
Now I will switch to the Melbourne router. And I'll explain and show the interface tunnel 10. So for that we have a command show interface tu and tunnel 10. So as you can see that the tunnel 10 is up and the line protocol is also up. This command confirms that the GRE tunnel interface is up and it's operational. After that, I'll also use the command to show IP route. So as you can see, the routing table also shows the reachability to the remote network through the tunnel. So for the further verification, I will try to ping the okay. As you can see, the success rate is 80%, which means we can still ping and then we can send the packet to the network of the Sydney branch. This successful ping confirms some secure communication between Melbourne and Sydney through the GRE VPN tunnel. So routing is supported using RIP, which allows traffic to flow through the tunnel successfully. Security and the reliability will be explained by Galley again.
Overall, the recommended improvements address performance delays, enhance reliability through redundancy, provide visibility using SNMP monitoring, and ensure secure inter-branch communication using GRE VPN tunnel. In conclusion, this video demonstrates the analysis of network issues, justified the commanded solutions, implemented SNMP monitoring and successfully configured a secure point-to-point GRE VPN between Sydney and Melbourne. This completes the assessment 3 demonstration. Thank you.
For the further verification, again, we can also ping from the PC of villain 10, so which means ping 172.91.10.0, and we can, as you can see, the ping is successful. And we can also try to ping from the PC of Etcher villain 72.91.0.10. So in this case, it shows that destination is unreachable, which means that we in a first assessment, assessment 2, we configured access control list, which means this confirms that the GRE tunnel works and the access control list still enforces security by allowing only IT villains users to access the Sydney servers. Only the IT villains can access the Sydney servers, whereas the IT villain, the HR villain cannot access. As you can see, it showed failed. Thank you.